Section 1.3, solving equations with variables on both sides. All right, so the steps to solve, very similar to Section 2, where we simplify each side of the equation. The difference here is that we've got one extra step. We're going to use inverse operations to get all the variables on one side of the equation. All the numbers then would go on the other side, and then we'll solve it like normal. Okay, so the real key, or the real difference, is this one, step 2. Use inverse operations to get the variables on one side of the equation. Does it matter which side of the equation? No, it doesn't. Most people are more comfortable with the variable on the left because we're used to writing answers like x equals 7 or 17 or 174 or whatever. Okay, so most people are comfortable with the variable on the left. That doesn't mean it has to go on the left. Sometimes it makes more sense for it to go on the right. And I'll give you an example of that here in just one second. Okay, so step number 1, simplify each side of the equation. If there's parentheses to distribute, do that first. Then use inverse operations to get the variables on one side of the equation, completely your choice, and then we'll solve it like normal. So there really aren't any major differences other than one extra step. All right, so let's get to it. Number 1, let's solve. How about 10 minus 4x is equal to negative 9x? Okay, so 10 minus 4x is equal to negative 9x. Clearly, we have variables on both sides. We got the negative 4x on the left. We got the negative 9x on the right. What I would tell you is I would put the variable over here. The reason being is that there's not anything else over here besides an x. Does that mean you have to put it on the left? No, you could move this 9x to the right and it would be perfectly solvable. Okay? Sometimes, though, it's easier to put things on one side as opposed to the other for ease of, I guess, eliminating some extra work. Okay, so I'm going to decide to put the 4x, the negative 4x, on the right-hand side of the equation just because then all the x's are already over there. Okay, so negative 4x, because I got to think of this as negative 4x. That sign out front doesn't go away. Okay, so that's like subtracting 4x. To undo subtracting, I need to add 4x. Okay, and just like before, if I add something to one side of the equation, I better be adding it to the other side as well. Okay, so the negative 4x, the positive 4x go away. On the left-hand side, I'm just left with 10. Negative 9x plus 4x on the right-hand side. If I owe $9, I give 4 back. I'm still down 5. Okay, so 10 equals negative 5x. And now we're at a one-step equation. This shouldn't take much more than about 5 seconds to finish. Okay, so we divide both sides by negative 5. 10 divided by negative 5 is negative 2. Negative 5's cancel, and we're left with x. So x equals negative 2. Not horrible, not terribly different than what we've been doing, just maybe one extra step. Let's try something maybe a little more difficult. I wouldn't call it difficult, let's call it an extra step. Okay, so how about 3 times the quantity 3x minus 4 is equal to 1/4. So now we're going to be working with fractions too. 32x plus 56. Now, obviously we have some distributing to do here. We have actually 2 sets of distributing to do here. We're going to distribute the 3 to the 3x and the negative 4 on the left-hand side, and we're going to distribute the 1/4 to the 32x and the 56 on the right-hand side. Okay, so the left-hand side, 3 times 3x is 9x. 3 times negative 4 is negative 12. Okay? Now, multiplying by 1/4 right here. Multiplying by 1/4 is the same thing as dividing by 4. So rather than trying to figure out what 32 times 1/4 is, we could think of this as 32 divided by 4. And 32 divided by 4, that's fairly easy. That's 8. And then we still have the x out front. And then 56 divided by 4 is 14, positive 14, because it was positive 1/4, positive 56. So 8x plus 14. Now it's very similar to the last problem. We need to make a decision. Do we want to put the variable on the left-hand side over here, or do we put it on the right-hand side? Does it matter? In the long run, no, it doesn't. I'm going to put the variable on this side this time. I'm going to move that 8x from the right-hand side to the left-hand side. Okay, this is positive 8x. I want it to be 0x. I'm going to do that by subtracting 8x. And if I do it to one side, I've got to do it to the other side. Okay, so 9x minus 8x is 1x. That's a really good thing because now we won't have to do any dividing. x minus 12 is equal to, those canceled out, I've just got 14 over here. Okay, this is a one-step equation from here. This is just like section 1. Add 12 to both sides, x is equal to 26, and there's your answer. Not terribly difficult. If you think about, where does the variable have to go, or where should it go to make it as easy as possible? Could you have done it on the right-hand side? Absolutely. You just would have had one extra step in dividing by -1. Does that mean it's wrong? Absolutely not. You still get 26. It's just maybe one extra step. Let's try another one like that. This is number 3. How about 1/2 times 6h minus 4 is equal to -5h plus 1. Let's try that again. Plus 1. Do we have 2 sets of distributing to do? No, but we still have some distributing. Half times 6h, half times -4. Half of 6 is 3h. Half of 4 is 2. Sign is still negative, is equal to -5h plus 1. Now, again, you need to make a choice. Do you want to put the variable on the right or the left? Most people choose to put the variable on the right. They take that -5h and move it over to the left-hand side, I said right, I meant left. This is -5h, so to make that 0, we need to add 5h to both sides. 3h plus 5h is 8h. Still have -2. Those cancel out, and I guess I don't need the plus 1. I can just make that 1. Okay? Now I've got a two-step equation. This is more like a section 2 equation now. I've got the variables on one side, so let's get rid of the numbers. I'm going to do that by adding 2 plus 2. The 2's go away. 8h on the left, 1 plus 2 is 3. And now I've got one's last step to go. I haven't used blue yet, so we'll use blue. We'll divide both sides by 8. Those go away. H equals. Now, 3 over 8. 3 divided by 8 is not a very good number. It's a decent decimal. It's 3 decimal places. If you want to write it as 0.375, that's perfectly fine. However, go ahead and leave it as a fraction. Leave it as 3/8. I much prefer this over the decimal. Okay, I'm more of a fraction person. You're going to find that out about me. I do like fractions better than decimals. That doesn't mean decimals don't have their place. But if you've got something like 3 divided by 8, like this answer right here, go ahead and leave it as a fraction, 3 over 8. Or something like if we had 4 over 11. This isn't a nice number. This is 0.36 repeating. I'm not a big fan of repeating decimals. I would much rather leave it like that. Okay, so that's kind of a little bit of a side note there. But don't be afraid to leave your answer as a fraction. Make sure it's simplified, but fractions will be your friend here as we get through Algebra 1 a little farther. All right, I do need to go over a couple more examples here for you because they're a little different. So this is, let's see, that was number 3, so this will be number 4. Number 4, how about 3 times 5x plus 2 is equal to 15x. Okay, same thing. 3 times 5x is 15. 3 times 2, oops, that's 15x. 3 times 2 is positive 6. And I've got 15x on the right-hand side. Now, I've got x's alone on the right-hand side, so I'm going to take this x right here, and I'm going to move it that way. I'm going to do that by subtracting 15x. Subtracting 15, I hope you see what's happening here. 15x minus 15x is 0. I've got 6 on the left-hand side. 15x minus 15x, I've got 0 here. Well, what do? I've got 6 equals 0. The last time I checked, 6 isn't equal to 0. Okay? So what happens here, if you get something mismatched like this, 6 equals 0, your answer here is no solution. Okay, there's a way to shorthand no solution. It's a circle with a diagonal slash through it. No solution. Like if you get something mismatched like 6 equals 0. Okay? Very similarly, number 5 here. Negative 2 times 4y plus 1 is equal to negative 8y minus 2. Distribute again. Negative 2 times 4y is negative 8y. Negative 2 times 1 is negative 2. and I've got negative 8y minus 2. What you notice, these two sides are exactly the same. Okay? The two sides of the equation are exactly the same. If you wanted to move the variables to the left-hand side, add 8y plus 8y, those are gone, those are gone. What's going to happen is you're out of variables again. Negative 2 equals negative 2. But this time, they match. Okay? If you get something that matches, your answer here, all real numbers. And again, there's a way to shorthand this. It's two vertical lines and you make an R on the left-hand one. Okay? Or it's an R with a vertical line through it, either way. Okay? The difference between, these two equations and the first three that we did, if you notice, in the first three, I never ran out of variables. In these two, I did. I didn't have any variables when I got to this step or when I got here. Okay, the key in order to have no solution or all real numbers is you have to run out of variables. If you don't run out of variables, then you still have an answer. Now, one quick thing. If you have something like 6x equals 0, this is not no solution because you still have variables here. Notice in these two, I don't have any variables anywhere. There's no variables there. There's no variables there either. But in this one, in this one down here, I still have a variable right here. So I still have an answer. Your answer here is 0. That's the only number that works. But in these, there's no number in the first one, this one. There's no number that makes it work. And then every number makes it work for this one. Okay, so just be aware, if you run out of variables, you got one of two options. You either got no solution or you've got all real numbers. If you have a variable at the end like this one, then you have only one answer.